Hi and welcome to this last video on the trapezoidal rule and the development of the generalised rule for using trapeziums to approximate the area under a curve. So you see here I've built a curve this time. It looks a bit like a cubic. It's not really meant to be anything. It's just y equals f of x. The point here is we're generalising, so we don't know what it is. So what we're going to do is build up a generalisation by first saying, let's imagine that we wanted to find the area between, let's say, here and here. And to build a generalisation, what we normally do then is we'll give them names, A and B. We're going to find the area between A and B. And the other important thing is that we need to determine how many strips we're going to use. So I'm going to stick with, I'll stick with 4, which is what we've used previously. It's the only time I'm not going to denote a value, but we could use n strips. And so we'll come back and we'll fix our formula at the end. But it's easier to draw if we have 4, okay? And then we can build up an understanding. So in this case our strips equals 4, but it could be n. And we'll come back and replace the 4 with an n later on. Now, to understand the height of each of these segments and then build an area of each trapezium, I need to find the coordinates. So this coordinate here is A, comma, something. And that something is actually going to be A, comma, f of A. That's x. A, comma, f of A. But we'll get back to that in a minute. What I'm going to do to start with, I'm going to call this h0, height 0, the 0th height. I'm going to call this h1, h2, h3, and h4. With that knowledge, I can build up the generalised formula, and then we can talk about how we find h0, 1, 2, 3, 4 later on. So here's the generalised formula. The first trapezium, the area will be, so I'll call this area 1, is equal to a half of height 0 plus height 1 times by what we call the width. But we're going to generalise even more with the width as well. So let's have a look at the width. So the width in this case is the height of the trapezium. We turn this on its side. And that's what we call the width. Now, the idea here is that we want all our trapeziums to have the same width. So hopefully you can see that the width in this case will be this length divided into 4 segments, later on into n segments. So the length is b minus a. You get the upper value, you subtract the lower value, and that's your length. So b minus a, but there are 4 segments, so divided by 4. The width is b minus a over 4. So I'm going to put that into my width. And so I get this. A half h0 plus h1 times by b minus a over 4. So that's the first bit. Now I might just might write it like this. B minus a over, and this is going to seem a bit weird, but I'm doing it for a very particular reason, 4 times 2 h0 plus h1. I could write 4 times 2 as 8, but let's just leave it as 4 times 2 for now, because that will be important when we get back to this n. So that's the first one, that's area 1. Hopefully you can see area 2 is equal to b minus a over 4 times 2, but this time my heights are height 1 and height 2. And area 3 is just the same, but with height 2 and height 3. And area 4, height 3 and height 4. So what I'm going to do is get my area total. My area total is b minus a over 4 times 2 h0 plus h1, that's area 1, plus b minus a over 4 times 2 h1 plus h2 plus dot 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 all the way to the end, area 3, area 4. But hopefully you'll see now that there is a common factor, and that is b minus a over 4 times 2. So our new improved formula will just take b minus a out as a common factor, and I'll be left with h0 plus h1 plus h1 plus h2 plus the next one will be h2 plus h3, the next one will be h3 plus h4. So it still looks pretty complex, but let's simplify that. b minus a over 4 times 2 h0 plus 2h1 plus 2h2 plus 2h3 h4. And my last little simplification before I show you some really generalised versions of this is we started with 4 strips. What if we started with n strips? Now you've got b minus a over 2n. h0 plus 2h1 plus 2h2, 2h3 plus h4, and that is the more technical, theoretical version of the trapezoidal rule. If you've got n strips and you know where your area starts on the x-axis, where it finishes, they're your A and B. N is the number of strips you're going to break it down into, and the heights are just the heights of each segment. That's a really formulaic trapezoidal rule. There are others, and they're better for remembering, but they're not quite as nice mathematically, but I'll give them to you anyway because you will find them. So others are, the main ones are, well the main one is that the area is equal to width over 2, because let's be honest, that's a bit complex. We could just get the width by saying, oh what's this divided by n? And in all the cases you're going to find this is 1, that's 5, so it's 4, n is 8, 4 divided by 8 is a half. So you can work it out pretty easy. But it's the width, whatever that width is of each trapezium divided by 2, times by, let me write it like this, ready? E plus 2m. You'll see that pop up. So it's a way that some people find easy to remember. Basically width over 2 times by the ends, h0 and h4, because they're only included in one trapezium each, plus 2 times the middles. h2 plus h2 plus h4 is the middles. They're included in 2 trapeziums each. So we get this. This is a bit of a different way of saying it, and you might also see a version that has h0 plus h4 plus 2 times h1 plus h2 plus h3, and of course there could be variance on that because h4 might not be the last one, it could be hn. So there'll be a few different variants, and I suggest you go and have a read of your textbook, have a play around with that, and just do some questions with it. That's going to be the easiest thing. The last thing I want to talk about very quickly is how we determine these h's. And I'm not sure how much space I have below me, so I'm going to just rock up here with this. So h0, don't forget h0 is when we substitute in a. So h0 actually just equals f of a. Whatever the function is, if you just put a into the function, that will give us the height at that point. What about h1? Well, h1 is going to be the height at that ordinate, and that ordinate is a plus a width. And you will have determined the width already. It might be that you're still using b minus a over 2, or over n, sorry, but you might have already worked out the width. So it's just f of a plus whatever your width is. h2 is equal to f of a plus 2 widths. It's not a plus 1, which is a mistake I see often. It's a plus whatever this width is. You'll often get easy questions at the start of an exercise, maybe early in an exam, where this width will be 1. So you start to get the feeling that it's 1, but it's not 1. It's whatever the width is, which might be a half, it might be 0.1, it could be 10. We don't know, and it depends on the context. But there it is. That's a bit more complex, but all you really need to know for the simple for me and even complex for me is just the formula. Be able to apply the formula, be able to find your widths and your heights and stuff like that. It's only really the complex unfamiliar that you're going to have to start to be able to understand where the formula comes from, because questions might be asked of you in a slightly different way. Anyway, I hope that makes sense, and hopefully you'll go through some examples. There's plenty out there. Read them, make sure you can do the questions, and most importantly, ask questions and ask them early. All the best.